Today we are going to learn about NumPy broadcasting in real-world data analysis. We'll explore how broadcasting simplifies operations on arrays of different shapes, enhancing your data analysis techniques.
Welcome to our video on NumPy broadcasting in real-world data analysis. Broadcasting is a powerful concept in NumPy that allows you to perform operations on arrays of different shapes, without the need for explicit looping. This not only simplifies your code but also makes it significantly faster and more efficient. Throughout this video, we'll delve into how broadcasting can enhance your data analysis techniques, from financial data manipulation to image processing, and integrating with pandas for data frames. Let's get started.
To begin our exploration, let's understand the basics of array operations with broadcasting. Broadcasting allows NumPy to treat arrays of different shapes during arithmetic operations. When you perform operations between arrays, NumPy compares their shapes element-wise, and if they are not compatible, it expands the smaller array to match the shape of the larger one. This process is done virtually, without actually copying the data, thus ensuring efficiency. For instance, when adding a 3x1 array to a 3x3 array, NumPy broadcasts the smaller array across the larger one. This mechanism allows for efficient vectorized operations without the need for cumbersome loops, significantly speeding up computations. We'll see practical examples of this shortly. Now, let's look at a real-world case study, applying broadcasting to financial data. Financial datasets often involve handling arrays of different dimensions, such as stock prices over time and different financial indicators. With broadcasting, you can perform operations like adjusting stock prices for inflation across different time periods with ease. For example, if you have an array of stock prices and a separate array representing an inflation adjustment factor for each year, broadcasting allows you to multiply these arrays directly, adjusting the prices efficiently. This not only saves time but also reduces potential errors in data manipulation, making your financial analyses more robust and reliable.
Broadcasting is equally valuable in the realm of image processing. Images are essentially arrays of pixel values, often with 3 dimensions representing width, height, and color channels. Broadcasting enables pixel-wise operations across these dimensions seamlessly. For instance, when normalizing an image, you might want to subtract the mean pixel value from each pixel. If you have a 3D array for an image and a 1D array for the mean values of each channel, broadcasting allows you to subtract the mean from each pixel across all channels efficiently. This capability streamlines the process of manipulating and analyzing images, making tasks like filtering, transformation, and enhancement much more manageable. In time series analysis, broadcasting proves to be an indispensable tool. Time series data, which consists of sequences of data points indexed in time order, often requires operations across different time intervals and adjustments for seasonality. Broadcasting simplifies these operations by allowing you to align data of different shapes. For instance, if you have daily data and need to apply a monthly adjustment factor, broadcasting allows you to apply this factor across the daily data without additional loops. This flexibility facilitates efficient resampling, interpolation, and transformation of time series data, making your analyses more comprehensive and insightful. Integrating broadcasting with pandas data frames can greatly enhance your data manipulation capabilities. Pandas, a powerful data analysis library, provides data frames that are ideal for handling structured data. By leveraging NumPy's broadcasting within pandas, you can perform operations across data frame columns efficiently. For example, when normalizing data, you might need to divide each column by its maximum value. Broadcasting allows you to accomplish this in a single operation, applying the division across all columns at once. This integration not only optimizes your computations but also simplifies code readability and maintenance, making it a valuable skill for data scientists and analysts.
When dealing with large datasets, optimization becomes crucial. Broadcasting offers a solution by enabling vectorized operations that are both memory efficient and fast. This is particularly important when working with large matrices or datasets that don't fit entirely in memory. By leveraging broadcasting, you can reduce computation time significantly. For instance, consider a scenario where you need to perform matrix operations on a large dataset. Broadcasting allows you to execute these operations without explicitly reshaping or copying data, thus conserving memory and accelerating processing. These optimization techniques are essential for data-intensive applications and can greatly enhance the performance of your analyses.
While broadcasting is a powerful tool, it comes with its own set of challenges. Understanding the rules of broadcasting is essential to avoid shape compatibility issues. NumPy requires that arrays have compatible shapes, or it will raise an error. Common issues include mismatched dimensions or attempting operations that are not supported. To troubleshoot these errors, ensure that the dimensions align and the operations are valid. Performance bottlenecks can also arise if broadcasting is not used correctly, leading to unnecessary computations. By following best practices and thoroughly understanding broadcasting rules, you can avoid these challenges and harness the full potential of broadcasting in your data analyses.
For those looking to push the boundaries of broadcasting, advanced techniques offer new possibilities. Custom broadcasting strategies involve creating operations that take full advantage of NumPy's capabilities. By leveraging functions like np.newAxis or np.expand_dims, you can manipulate array shapes to fit specific needs. These advanced operations enable you to handle complex data transformations and analyses efficiently. Additionally, exploring case studies can provide practical insights into how these techniques are applied in real-world scenarios. By mastering advanced broadcasting, you can enhance performance, streamline workflows, and tackle complex data challenges with confidence. In conclusion, NumPy Broadcasting is a transformative tool for data analysis, offering efficiency, speed, and simplicity in handling arrays of different shapes. From financial data to image processing and time series analysis, broadcasting provides a versatile solution that enhances your analytical capabilities. By understanding the intricacies of broadcasting and integrating it with libraries like Pandas, you can tackle complex data challenges with ease. As you continue your learning journey, consider exploring more advanced topics and applying broadcasting techniques to your projects. Thank you for watching, and we hope you found this video insightful.